Okay, now that we have talked about the setup and what it looks like, let's hop into some playbook action. The first thing that we want to do is use the Ansible ping function to ensure our device's Ansible is tracking in the host file, or reachable. Ansible has a few wildcard words it recognizes by default, making it easier to identify things as you go. One of those words is coincidentally all. So if we look at our host file, let's do this. Here's our host file. Notice I don't have an all in here. There's no all variable identified, but luckily Ansible knows what I mean when I say it, so I'm going to type Ansible M and then ping all. So what I'm going to do is I'm basically targeting all of my Ansible hosts here, alright, and I want to ensure that we're able to reach our identified host. The M in this case is to identify the module, which is the command of ping. So as we can see, Ansible is attempting to reach all of our devices, and once we confirm all, then we are ready to run some playbooks. Considering this video mainly focuses on Cisco and Linux, I have a fun way to make sure my Cisco devices are reachable and that I'm continuously saving my progress periodically and frequently. I conveniently name this playbook Save Configs because that's exactly what it does, and here is that playbook. Using the iOS config module, I am just instructing all of my Cisco devices to save their running configurations, which is always best practice. So, and that's this module here. So how do we actually execute a playbook? All right, it's pretty simple. The first thing we would want to talk about is terminal. All right. I may have failed to mention that Ansible works best when deployed on Linux devices. So here in terminal, we would type Ansible -playbook, and then the name of our playbook, which in our case is Save Configs. All right. Keep in mind you need to be in the same directory. So in my case, I am code and sandbox. That's where all my files are. Or it won't find the files that you're trying to execute. Now, if you look, let's see. So let's go here, and we'll execute this. Now, if you look in the console connection to one of the Cisco devices, we'll just pick router 1 for this instance. We can see the console output indicating that our Ansible controller opened and closed an SSH connection to our network device. It's pretty straightforward, and I hope you see the power of this tool by this simple playbook. It's not rocket science. It's just an easier method than manually having to console into devices one by one and run simple configuration tasks. All right. So as we can see here, here's our source, which is my Ansible controller. Our local port is 22, so that indicates SSH. And then we exited right here. All right, so that's useful information. All right, let's talk VLANs. All right, and as you can see, this executed, without any errors. One thing to note: if you look at the yellow text here, that indicates something has been changed. All right, and anytime you save a configuration, something has changed. So if it had not changed, this text would be in green. So that's a cool little function that Ansible gives you. But anyway, let's talk VLANs. Everyone loves to segment traffic on the network, so here we're going to implement some VLANs on our switches to segment our PCs. So, as depicted in our topology, we have two switches, switch 1, switch 2. And we want to configure VLANs 10 and 20 on switch 1 and 30 and 40 on switch 2. For, let's see, for my playbook named interface VLANs, I combined a few modules here. These modules can be found in Ansible's documentation, which lists various Cisco options for the user. And I will quickly show you what that looks like. Let's see here. Let's go to my bookmarks. So as we can see here, our Cisco iOS is what we're using. So if you look down into these modules, the modules that I ended up using was our interfaces module, our iOS layer 2 module, and then ultimately our iOS VLANs module. All right. So if you click inside of here, you'll get great information on how to implement and obviously good examples of what to do. All right. For this, I use the iOS VLANs module to first create my VLANs, then the iOS interfaces module to configure individual interfaces, add descriptions, and enable these interfaces. I then use the iOS Layer 2 interfaces module to configure my VLANs both trunk and access. I ended up separating this playbook and listed switch 1 and switch 2 in separate areas. There are definitely ways to cut this text down by using additional parameters, but there will always be ways to improve your code. But this was just the direction I chose. So in this instance, I have switch 1 here. I'm giving it its configuration parameters, and then I separated it into switch 2. Okay. So here, the playbook, and we'll just take switch 1 for this instance. We're going to create VLANs 10 and 20, and this, when you name your names, this is your way of telling yourself what you're doing. I gave the VLAN an actual name, assigned it a number, made sure it was active, and the state is merged. And the reason this is important is because if you do have existing VLANs, say you already have VLAN 10, but you want to rename it, it's going to merge that configuration and ensure that it overwrites it. All right. Second, I use the interfaces module to give my interfaces physically switch port descriptions, make sure that they're enabled. And then I assign my interfaces to either access or trunked VLANs. All right, so made them either trunk ports or access ports. And here I specified which VLANs I wanted allowed over the trunk, and then ensured that I told it which encapsulation I would want to use. And as always, in all my playbooks, you'll see this with Cisco especially, I always save the running config when I am done executing my commands. Okay, so let's hop over real quick to, let's go to switch 1. All right, and then we'll log into this real quick. And you know what? We'll also do this with switch 2. We'll do 2 at once, and then I'll go ahead and log into this guy as well. All right, so as we can see, I have on switch 1, I have VLANs 10 and 20, and then on switch 2, I have VLANs 30 and 40. All right, so what I'm going to do now is I'm going to delete these. All right, I'll do this manually. So no VLAN 10. And no VLAN 20. Alright, do show VLAN brief. They're gone. We'll do the same thing over here. No VLAN 30. And no VLAN 40. Do show VLAN brief. And those are gone. Got it. Alright. Don't worry about these duplex mismatch. This is just a switch port that I enabled as a routed interface to ensure that my Ansible controller can reach it via IP. Alright, so we see that our VLANs are no longer present. So now let's have Ansible automate their creation. Alright, so we'll go back to our Ansible controller. We'll go ahead and clear this out, and we will execute our playbook, which is Ansible playbook interfaces VLANs. Alright, this is targeting our switches. So we'll go ahead and execute this. Notice that the names that we create for our plays are readable in terminal. So I would just recommend, it's up to you to make yourself understand what you wanted Ansible to do. All right, so we'll give this a second to go ahead and finish. Obviously, Ansible targets this host by SSH. It's not the most effective when it comes to super large management of systems, just because it's going to execute one by one. Now, you can run the same playbook in multiple terminals. That's one way to kind of do it, but that can also get a little bit messy. But let's let this go. And as we can see, just from top to bottom, we created our VLANs, we set descriptions, access and trunks, we saved our configurations. Everything looks good. So let's go ahead and head back to our switches. So switch 1, switch 2, and obviously we get the same output. We could see that SSH connection was made. All right. So we hop back here and we'll go ahead and do show VLAN brief. Same thing here, do show VLAN brief. And we see our VLANs are back. So that was pretty powerful. Looked good. Keep in mind that this is only 2 switches, but imagine if you had 20, 30, or even 50 that needed servicing. All right, Ansible helps us automate these, minute but tedious tasks through a single playbook, and the playbook doesn't take too long to write. All right, so it's a pretty powerful tool. All right. I'm not going to show you connectivity between our endpoint hosts because, as you know, a VLAN will segment, and it's pretty simple to test out. So I'm going to leave that to your imagination. But let's talk about routers. All right, going back to our diagram here. The routers in this topology are running OSPF version 2, so IPv4, and they're separated into 2 areas. Area 0 on our host networks, and area 1 on our routed network, or networks. You could obviously just make this a single area, but I figured I would show that multiple areas work as well. I'm running a super basic OSPF setup, and I want the networks to be aware of each other, to include my networks serviced by my subvirtual interfaces, or SVIs. I'm not going to get into the weeds of OSPF v2 since this is an Ansible tutorial, but I want to show you how powerful Ansible modules can be when dealing with multiple routers. So let's take a look at our playbook. So we'll pop that guy back up here. And let's head over to OSPF. There we go. I've simply labeled this playbook ospf.yaml for obvious reasons, but I also want to take a look at the Ansible documentation. All right, so let's go back to our Cisco documentation with Ansible, and we'll go to our OSPF v2 module. All right. So again, the Ansible documentation is actually really good. It's going to kind of give you the overview of what you would want to know. All right, and a lot of these are going to be pretty known to most network engineers. So obviously our address family, adjacencies, our areas, what else? Ranges, yeah, stub networks, auto costs, bidirectional forwarding detection. Let's see, what else? Compatible, yep, RFCs, default information. So a lot of information that's widely known. And I have noticed that Ansible documentation has kind of matured over time. Before, a lot of people, when they use Ansible, they will bypass a lot of this stuff up here and immediately go to an example on the bottom. All right, this is what we want to see, right? So because this is what we're going to be implementing into our playbooks. So I'm going to skip the part where we're deleting all of our OSPF processes, right? And I'm going to show you, this is just giving you multiple different types of possibilities that you could use if configuring OSPF version 2. And the way that it's matured is it will actually tell you, based on the YAML text and code that you've produced, these are the commands that are going to be fired at the router, okay, or routers, I should say. So it gives you an after state, which is great because this is going to this looks to most network engineers like Cisco output, and that's what we're used to. So that's what we want to know, what's being executed when we run our playbooks. And then it also gives you a before state. So this is what was on the router before, and then once we executed as we were supposed to, this is our after state. All right. All right, let's get out of the documentation. You can feel free to Google that. And let's look at our playbook. So like I said before, Ansible gives you multiple options to choose from when deploying our code. If you look at my comments here, you can see that I have tested the commented code up top out. And the reason is because I found it was not stable, like whatsoever. I would run the code on a bare router and the devices accepted it, but when I ran that same code on a configured device, it failed. All right, so it didn't like when I was trying to overwrite what was already on that router. All right, and that was because I used the iOS config module for manual commands that I wanted to implement. So that is a possibility. All right, but I ended up going to the documentation, which saved me in the long run. And you know, it provided me a much better solution. So after I updated my code, I found that I could run this whenever I wanted to, and it would not fail, because really it comes down to the state of merged. All right, and this is where Ansible is telling it, I don't care what's on your device, we're going to overwrite it, and we're going to merge it into the configuration that exists. So if you have configurations that are outside the realm of what you have manually put here, it will not overwrite that configuration, but it will merge your new configuration with your current. Okay? So it made a lot of difference, and it's exactly what I needed. So here you can see the networks that I want added to my OSPF areas. And as I said, I want them to all know about one another, so each router will get these networks added to their OSPF databases. There are obviously several other options we can configure with Ansible, such as domain IDs, authentication methods, costs, passive interfaces, etc. But for now, we're just going to configure OSPF v2 with router IDs, networks, process IDs, and area IDs. Notice I have manually defined my router ID variable. And how I did this is through the use of the host file. All right. I know I kind of talked about this last video, but I want to reiterate just how powerful this file can be. Because I am able to assign my router ID per the host inside this file. All right. And I only have to do it once for reuse with my code throughout various playbooks. Then from here, the rest is fairly straightforward as to what we were trying to do with our OSPF configurations. And as with most, if not all, of my playbooks, when dealing with devices which encompass non-volatile RAM, I always save my configurations when I'm done. All right, just best practice. So let's go ahead. Let's move over to router 1. So we'll go to router 1 first, and let's go ahead and log into this guy. All right, and notice that SSH is, already previously been configured. I mentioned that before, but it's pretty paramount. Well, it's required for Ansible to talk to it, so we have to make sure that's probably the most time-consuming of all of your tasks. So let's see. Let's look at our OSPF configuration. So we'll do a show run section OSPF. All right, so as you can see, we do have an OSPF configuration on here. All right. Let's see. Yeah, we can see we have it active, so it should allow our endpoints to communicate. All right. So let's test that communication quickly. All right, so going back, here's our topology, our endpoint PCs on both ends of the network. So let's go ahead and test that out. And for clarity or brevity of time, We'll take PC1, and then we'll just go to PC4. All right, I'll open this up so hopefully you can see it a little better. I know my VMs are super small. And we will try to ping each other. So I'll go ahead over here. And the first thing I'm going to do is ping PC4. We can see that I'm good there. And then I'll even ping PC3. And we are good there. And then I'm going to do the same over here. So let's ping PC1. Or I guess in this case it'd be PC2. And PC1. All right. So as we can see, we have bidirectional communication. All right. And that's what we want. So now let's take OSPF out of the equation. We'll start with router 1. We'll simply negate the OSPF process ID, which will also delete all of our networks within our OSPF configuration. So in essence, we're deleting OSPF off this router. All right, so let's go ahead and do that real quick. So we'll go back to router 1. And then from here, all I'm going to do, I'll go ahead and copy that, get into global configuration, and I'm just going to do a no router OSPF1 do show run section OSPF. And as you can see, we lost our adjacency, so that's gone. All right, and we do not have any running configuration for OSPF. All right, and we can confirm that because now when we try to ping back and forth, oh, got nothing. All right, same thing with PC4, got nothing. Can we ping over here? Nope, we're down. All right. So we, yep, our neighborship's down. We can't ping back and forth. So let's head back to our Ansible controller, and we're going to have Ansible configure OSPF for us now. For purposes of the video, we're going to limit this playbook to just router 1 at the moment, and we're going to run this playbook. All right. On top of that, we're going to add some debugging to this process so we can see some expanded information for our viewing pleasure. All right. So let's go ahead and go back to our controller real quick. And we'll go ahead and run our OSPF. Let's clear this out so you can see it. Ansible playbook, OSPF. I'm going to limit this to just R1. And then I'm going to add some debugging, and as you can see, it's just VV. It's different levels of debugging, so VVVV is like the most that you can possibly see. So let's go ahead and run that. All right. So it's going to provide you a whole bunch of back-end stuff. Ansible is written in Python, so it's a lot of things that it's going to tell you. Okay. All right. So as we can see, this debugging, and we were successful. Obviously, we're in yellow here, so that tells us stuff changed. All right. So we're gonna look. It's gonna allow us to see what was previously configured. All right. So let's go up here. All right. So you see this before. This was on here before, right? And this tells us exactly what we want to know. All right. And then obviously what was changed. All right. So that's where this comes into play. So this is going to tell us exactly what has changed. It's going to tell us our address, our network, our area, our wildcard for our subnet mask. And yeah. And obviously we added our process ID of 1 and our router ID of 10101010. All right. So let's see. So looking deeper into this module debugging, we can see possible configurations available to us if we in fact wanted to implement them, such as, let's see. Yeah, here we go. Such as address family, areas if we wanted to list them out, bidirectional forwarding or BFD. This is all based on the Ansible OSPF v2 module, and it's great to know because we have this ability if we wanted to actually add it. All right, but in our case, we just wanted to do a simple configuration. Okay, so now let's go ahead. Let's head back to router 1. Nope, that's switch 1. We don't want that. So let's go back to router 1. There we go. All right. And what we want to do is to see if we had an adjacency form. And then if we do, let's ensure our endpoints can communicate again. All right. So what I'm seeing here, I do not see an adjacency. Just, yeah, oh, yes I do. Right here, loading to full. So let's do a do show IP OSPF. It would help if I could spell neighbor. And there we are. All right. Okay, so we're good there. So let's go back to our PCs and let's make sure that they're able to still talk. So let's pull up PC1 again, and we'll pull up PC4. Are we able to speak again? Yes, we are. All right. So there's PC4. There's PC3. Can we do it from the other end? Are we looking pretty here? Yep, we're good to go. How about PC2? Yep. All right. That's good. All right. So that kind of is, the OSPF, well, the power of Ansible to configure something such as OSPF. All right. But lastly, I'm going to negate all of my OSPF configurations off of all 3 of my routers. Then I'm going to have Ansible reconfigure them to see automation of multiple devices in action. All right. So let's go ahead. We're going to minimize this. Let's go ahead and bring up all of our routers. And then we're going to delete all of our OSPF configurations off. Okay? So I think no router OSPF1. Boom. That's done. What do we have here? T. No router OSPF1. And we'll do the same over here. So on router 3. Configuration, and we'll do no router OSPF1. Okay. All right. And then, this, we already proved before that does in fact negate all of our OSPF configurations. And just in case you don't believe me, we'll go back to PC1. Let's clear this out. And are we able to ping across? No way. We don't have any route to get to where we need to be. All right. So that's going to fail. All right. So let's go back to our Ansible controller. Let's clear this out. And now I'm going to run this command again. However, I'm going to get rid of the debugging. And I'm not going to limit it because I want it to touch all 3 of my routers. So router 1, 2, and 3. All right. I know it's not a super large amount of network devices, but it's more than one. So let's go ahead and run this. This will take a little bit of time because it's going to go ahead and automate all of those at one by one. Sorry. But using the use of one playbook, which is always a nice thing. And now we're saving our running configuration. We definitely want that. So now let's bring our routers back up. Routers, especially with any kind of dynamic protocol, they take a minute to converge. So let's go ahead and kind of clear this out a little bit so we can see what's going on. And then we're just going to wait a second. And I'm not sure. Okay, there we are. Okay, that looks beautiful. There's nothing better than seeing your adjacencies form. That's exactly what we want. So, the true test is, now that we've blown out OSPF, and we want to make sure that it's been configured with Ansible, let's go back, and let's see if we can ping. And look at that. We can. That is a beautiful thing. So PC1 can hit PC4 and 3. And how about PC4? How are we looking? Can we get back? Sure can. All right. How about our other PC? Yep, that looks good. All right. Well, that's pretty much what we were looking for, and I would consider that to be a successful run of how we're using Ansible. Alright, so more to follow. That's all for this video, and I do look forward to seeing you in the next one. Have a great day.